Alright, so we'll go over some interesting questions under limits. So let me just show you the questions we're going to answer. So you can check question 1. We just have a few questions we have to simplify. And then look at the others. Question 2. Question 2 as well, we're simplifying. Question 3, question 4, first principle. And then we have, these are other questions that have been answered under differentiation as the odd topic. So watch a video to the end to understand all these concepts. So let's start with the limits part, the very first one. Okay, very interesting. So that's basically where we're going to start from. Okay, so evaluate the following limits. So for the very first one, how do we handle it? I believe at this point you've already watched the video where I've explained the concepts under the limits. If you've not, the link is in the description below. So the limit as x approaches 5, and then we have 2x squared minus 3x plus 4. So each time you're given a question to deal with a limit, just substitute the value you have. Don't only substitute if it's going to give you an error. Now in this case, if we substitute the 5, we're going to have the limit as x approaches 5, and then we're going to have 2, where there's x, we're going to put the 5. Okay, so that's what I've done. Whether we had x, that's where I've substituted this 5. So at this point, 5 squared is 25 times 2 is 50 minus 15 plus a 4. So that's going to be 50 minus 11. That's going to be a 39. Okay, so that's how we simplify the limits. That's how we've done the first one. Okay, let's move. Now if we go to 2, part 2, things begin becoming interesting. Here we have the limit as x approaches negative 2, x to the power 3 plus 2x squared plus 4 over 5 minus 3x. How do we simplify this limit? How do you go about it? So basically, let's try to understand what we can do. Does it have an effect if we're going to substitute the value of negative 2? Okay, so let's try. So where there is x, we're going to put the negative 2 on top, so we're going to have negative 2 to the power 3 plus 2. Where there is x, again we're putting a negative 2. Okay, and then on the bottom, where there is x again, where there is 3x, where there is x, we're going to put a minus 2. Let's see. So at least on the denominator we don't have a 0. On top, what do we have? So negative 2 the power 3 is going to be a minus 8. Negative 2 squared is positive 4 times 2. That's 8. And then we have plus 4. Negative 2 times negative 3 is going to be a positive 6. So 6 plus 5 is 11, right? So this is going to subtract. And then we'll have a 4 over 11 as our result. So the key concept is when you're raising a number, negative 2 to the power 3, it means negative 2 times negative 2 times negative 2. So that gives us a minus 8. Okay, so we just substituted directly because there was no error that we were getting. So with what you've learned, feel free to pause the video and try out the next one. So the third one, here we have the limit as u approaches negative 2. So the square root of u to the power 4 plus 3u plus 6, right? So this is what we have. We have to evaluate the limit as u approaches that. Now the question is, are we going to get any error? Let's substitute. So the limit as u approaches negative 2. So where there's u, we're going to put negative 2. So negative 2 to the power 4 plus 3. And then negative 2 where there's u plus a 6. So what do we have? So negative 2 to the power 4 means negative 2 times negative 2 times negative 2. That's going to be positive 16. Okay. and then that's going to be minus 6 plus a 6. So you notice that 6 will subtract, so you remain with just the 4 as a result. So that's the limit. Simple and straightforward. Simple and straightforward concepts. Now we're on number 4. Number 4, here the limit as x approaches 2, x squared plus x minus 6 over x minus 2. Now this is a part where if you substitute a 2 where there's x, you begin to have the denominator now becoming a 0, which makes the whole expression to be undefined. So at this point, what we usually do is ensure you factorize. Okay, so x squared plus x minus 6, that can be expressed as its factors. So let's look at what we have. The product is 1 times negative 6. So the product is negative 6. The sum is the coefficient of the middle part, which is a 1. What two numbers can you multiply to give you negative 6? You add them, they give you 1. So that should be 3 and a 2. So negative 2. So that it give us a negative 6, and then when you add, we get a positive 1. So if you've got a coefficient of a 1, then you're going to have just x plus 3 and x minus 2, since these are your factors. So we'll just add x. This only applies when the coefficient is a 1 of x squared. If not, then just substitute on the middle part with 3x and minus 2x. And then group them, and then factor out, you still get the same result anyway. So at this point, this is reducing to the limit as x approaches 2. We've expanded it to x plus 3, x minus 2. That's for the numerator. The denominator is 2x minus 2. So we're trying to do away with x minus 2 because it's making the denominator to be undefined. So we can divide, and then we remain with a limit as x approaches 2, and then we just have like x plus 3. So at this point, you know, when you plug in a 2 there, you're going to get the 5. So that's the limit, right? Simple and straightforward. Now proceed. We're on the next one now. So the limit as t approaches 5, and then you have x minus 5 over x squared minus 25. So how do you handle this one? So equally this one, if you're going to substitute in the t, I think this is an error. So you can't have a t and then we're having x. So let's just say it's x. So x approaches 5. So you're going to see that you're going to get a 0 over a 0. This is undefined. So equally here we're supposed to, here we apply a difference of 2 squares, since we know the limit as x approaches 5. For the top part we have x minus 5. The denominator we have x squared minus 25. So that can be expressed as 25 is the same as 5 to the power 2. And then we have the limit as x approaches 5. So a difference of 2 squares implies you can come up with 2 of them and then just change the sign. So we can have x minus 5 and then also x plus 5. That's what a difference of 2 squares is called. So even in a case where you have x squared minus 1, it can still be expressed as x squared minus 1 squared. And then as a difference of 2 squares, you can have x minus 1 and then also x plus 1. Very important. So you can clearly see equally here you can divide, so on top you're going to remain with a 1. And so therefore you have the limit as x approaches 5, 1 over x plus 5. So if you put a 5, you're going to have 1 over a 10 as your solution. Okay. So we were done with number 5. The next one. So how do you determine the limit as x approaches 7, root of x plus 2 plus 3 over x minus 7? Now this is a very funny question. Why? Because if you're going to plug in again there, it's going to be unusual. Now feel free to pause the video and try it out. Now you will notice that this one is different in that you can't factorize what is on top. you can't factorize what is on top. So there is no way you're going to cancel out this part. Okay, there is no way you're going to cancel it out. You can try to multiply by the changing the sign, everything. This is not a sad, so still it won't work. So we'll just apply L'Hopital's rule, which tells us that if you're going to have something like this, if you differentiate the top part and the bottom part, try if it's going to work. So let's try to differentiate the numerator and the denominator. So for the numerator, what's the derivative of what we have? So the expression we have is like x plus 2. Square root is the same as the power half plus a 3. So how do you differentiate that? So the derivative there is going to be, we're going to apply the chain rule. So 1 times half is half. Reduce the power by 1, it becomes negative half. The constant will disappear. So whenever you've got a negative power, you can take it to a denominator so that it becomes a positive power. So you have x plus 2, the power half. Now you know that half is the same as the square root, so it's going to be 2 root of x plus 2. That's for the top part, so we have the limit as x approaches 7. So after differentiating the top part, you have 1 over 2 root of x plus 2. Now for the denominator, what's the derivative of x minus 7? So it will just be a 1. Now you notice that the 1 basically doesn't have any difference. So ultimately all we have is just this part remaining anyway. So at this point we're at liberty of substituting. That's if it's not going to be undefined. So we're going to have 1 over 2 root of, where is x, we're going to put a 7 plus 2. So we have 1 over 2 root of 9. So we have 1 over root of 9 is 3. So 2 times 3. So you end up with 1 over 6 as the limit for this beautiful question. Okay, let's move on. With what we've learned so far, feel very free to pause the video and just try out the next question. So how do you handle the limit as x approaches negative 4 for x squared plus 5x plus 4 over x squared plus 3x minus 4? How do you handle this one? So obviously, to make things easier, we are just going to factorize in advance even before trying out anything. So it's possible we may get a 0. Let's try the denominator. The denominator is going to be negative 4 squared plus 3 times negative 4 minus 4. So this is going to be a 16. That's going to be a minus 12 minus 4. So this is actually a 0. So we can't just substitute directly. So let's try to factorize what we have. So the first one, the numerator is x squared plus 5x plus 4. The product here is a 4. The sum is a 5. Think of two numbers that you can basically multiply to give you a 4. You add them, they give you a 5. So basically we have 1 and a 4. 1 times 4 is a 4. 1 plus 4 is 5. So whenever you've got a coefficient of 1, so you're going to have x plus 1 and then x plus 4 directly. Okay. So the limit as x approaches negative 4. So for the top part we have x plus 1, x plus 4. We can look at the denominator. Feel free to pause the video and factorize it. So we have x squared plus 3x minus 4. What's the product? The product here is a minus 4. The sum here is a 3. So the product, multiply the coefficient of x squared and the constant, and then the sum, get the coefficient of x. So what two numbers can you multiply to give you negative 4? You add them, they give you a positive 3. So obviously that would be a 4 and a negative 1. 4 times negative 1 is negative 4. 4 plus negative 1 is a positive 3. So we've got a coefficient of 1, so it's just going to be x plus 4, x minus 1. So x plus 4, x minus 1. So don't forget we were dividing them. So we factorized both the denominator and the numerator. So we can see that can divide. So we have the limit as x approaches negative 4. We're remaining with x plus 1 over x minus 1. And then we can beautifully substitute. So on top you're going to have negative 4 plus a 1, negative 4 minus a 1. That's going to be a minus 3 on top. On the bottom, that's a minus 5. So that gives us 3 over 5 as a solution. Interesting, right? Simple and straightforward. Be at liberty of pausing and trying out this next question. The limit as x approaches 2, you have x squared plus x minus 6 over x minus 2 raised to the power 3. Okay. So how do you look at this one? What are we supposed to do? If we're going to go with direct substitution, you notice that the denominator is going to be a 0. So let's try to prevent that. So looking at what we have on top, we have a quadratic, so we should be able to factorize that. X squared plus x minus 6. The product here is negative 6. The sum is 1. Factors, what two numbers can you multiply to give you negative 6? You had them give you 1. Should be a 3 and a 2. Now for us to have a positive sum, it means negative 2 is supposed to be there so that we have a bigger positive number. 3 times negative 2 is negative 6. 3 minus 2 is 1. So therefore, after factorizing, you're going to have x plus 3, x minus 2. So what do we have? So we have a limit as x approaches 2, and then you have x plus 3, and then x minus 2 over x minus 2. All this is raised to the power 3. So this and that will divide. So the denominator, which was reading to a 0, has finally been dealt with. So at this point, what we're remaining with is we're remaining with the limit as x approaches 2. Numerator, we have x plus 3 as the only remaining part. Everything else has been cancelled. So plug in a 2. You're going to have 2 plus 3 raised to the power 3. 5 to the power 3. 5 times 5 is 25 times 5 is 125, is it? Okay, so that's what we have as a result there. We are now on question, should be 9. So you're still at liberty of pausing the video. So you have got the limit as h approaches 0 for the square root of 1 plus h minus 1 over h. So here we're now having surds. Okay, we'll apply the concept of the conjugates here. You know that if you're going to plug in a 0 for h, it's going to be a 0. You can't divide by a 0. So we can avoid this by actually multiplying by the conjugate of the numerator. The conjugate implies we change the sign. So I have 1 plus h, we change the sign in between so that we have plus a 1. Whatever you do to the numerator should be done to the denominator. So this applies even if we had done h on top. You could basically do this. Let's see. So whenever I'm multiplying a conjugate and a surd, this applies even to complex numbers. Just multiply the like parts. This times that, the brackets basically are going to disappear. So you're going to just have 1 plus h. Negative 1 times 1 is going to be a minus 1. On the bottom, we'll not simplify anything. We'll leave them as ai. Product of h plus 1 plus h plus a 1. Okay. At this point, 1 and the minus 1 are going to subtract. So remain with the limit as h approaches 0. And then you have h over h. Let me basically show this on the next step better off. so that you can clearly see what I'm writing. So what we have here is the limit as h approaches 0. We have h over h, and then in the brackets we have 1 plus h plus a 1. So the h can divide clearly. So therefore you have 1 over root of 1 plus h. So obviously h, you can plug in a 0 at this point, plus a 1. So therefore what you have is 1 over root of 1 is a 1 plus 1, so that's a 2. So I have 1 over 2 as the result. So just multiply by the conjugate. I think at this point you should be able to answer the next question without any challenges. The limit as x approaches 2, and then you have x to the power 4 minus 16 over x minus 2. So here what we have is the limit. Okay. What you can see is if we're going to substitute directly into the denominator, basically what you're going to see, what you're going to see is you see that we have a 0 in the denominator. So at this point, this I believe we can write it as the limit as x approaches 2, and then we have x to the power 4. 16 can be expressed as 2 to the power 4, right? Over x minus 2. Okay. Now here the question is, can we factorize the, are we able to factorize the x minus 2 so that we cancel it out? Okay. So that we cancel it out. So I think I would apply other concepts like synthetic division. Yeah, let's try synthetic division. So we are dividing x minus 2. So x minus 2, if we are equate it to 0, we'll find that x should be equal to 2. So for synthetic, what you do is you write down your 2 somewhere this side, draw a line, write the coefficients of whatever you have. So here we have x to the power 4, right? So it's down, so I have x to the power 4, so a coefficient of x to the power 4 is just what? A 0. Oh, it's a 1. So 1, and then x to the power 3, we don't have anything, x to the power 2, we don't have anything, x to the power 1, don't have anything, not until minus 16. So all these will be assumed to have coefficients of zeros. So 0, 0, 0, and then finally we have the constant. So what you do is for the first one, just put it down, and then you'll be multiplying by the 2 now. 2 times 1 is a 2, plus 0 is a 2, 4 plus 0 is a 4, that's 8, that's now 8, so that's now 16, remainder 0. So at that point, what you have after dividing is this. So since we had started with the power 4, this will be the power 3, the power 2, the power 1, and the power 0 as a constant. So what we have after dividing is x to the power 3, 2x squared, plus 4x, plus 8. You can use long division if you want. So what we have the limit as x approaches 2. For the top part, after dividing by x minus 2, which was x is equal to 2, we are getting x to the power 3 plus 2x squared plus 4x plus 8. And for sure, if you are going to divide these, if you are going to multiply the 2, you are basically going to end up with what we had, this one. So x minus 2. So at this point, this is now able to divide, and we can just plug in a 2 for the remaining part. So we have 2 to the power 3, 2 to the power 2, 4 multiplied by 2 plus 8. So 2 to the power 3 is 8, 2 squared is 4 times 2, that is 8 again. This is 8 again. That is 8 again. So the question is 8 times 2 is 16 times 2 is 32. So that's how you handle this question. Simple and straightforward. So we're now on question number 11. So you have a limit as x approaches -4. Then you have 1 over 4 plus 1 over x over 4 plus x. So how do you handle this one? So what do? We'll take a step. Let's try to deal with a numerator. Since we've got fractions, I think we can come up with a common denominator there. Why are we not substituting directly? If we plug in a -4 as x, we're going to get a 0 on the denominator. So we are trying to avoid that. We're trying to try other ways of dealing with it. So we can come up with a common denominator for the top part. So that can be 4 times x, which is 4x. 4 into 4x is going to be x. X into 4x is going to be a 4. So we know that after multiplying by the ones that are numerators, there will be no difference. So that's why we're just maintaining x and 4. Bottom, we just have 4 plus x. Okay. So that can be written as, of course, don't omit the limit as I have. Yeah, don't just omit it. So at that point, what we have is like the limit as x approaches -4. Now it's like we have x plus 4 over 4x, and then we're dividing by 4 plus x. So dividing by something is as good as multiplying by the reciprocal. So that's as good as multiplying by 1 over 4 plus x. So which will just give us the limit as x approaches -4. For the denominator, we're just going to have 4x multiplied by 4 plus x. The top part, we have x plus 4. Okay. So x plus 4 and 4 plus x are just the same. They can cancel, can divide. So we have the limit as x approaches -4. And then on the top part, we have the 1, bottom we have 4x. You can substitute. So I have is, if an x, we're going to put a -4. So you end up with 1 over 16. So it's -1 over 16. Okay. That's where we've ended for this question. So there are a lot of ways, as you've seen from the questions we've attempted, there are a lot of ways of you trying to avoid a negative denominator. There are a lot of ways. Now let's look at question 12. Here we have the limit as t approaches 0, and then you have 1 over t minus 1 over t squared plus t. Now this question is very funny because if you try to substitute where we have t, you're going to have denominators of 0, 1 over 0 minus 1 over 0, so we can't simplify those ones. Okay, so what can we do? So let's try to combine them. Let's try to subtract. We see what we're going to have. So 1 over t. Now the other part, if I factorize out a t, I'm going to have t plus a 1. Okay. So just trying to show you that if I'm going to come up with a common denominator there, it means t plus 1 is a common denominator. So if I'm going to divide by t, I'm going to remain with t plus 1. And then if I'm going to divide by the whole thing, I'm just going to remain with minus 1. So we have limit as t approaches 0. So I've just performed basic algebra here. And so what remains, we have the limit as t approaches 0. For the top part, only a t will remain. And then the bottom, we have a t and then t plus 1. So we have the limit as t approaches 0. So t over t and then t plus 1. So this can divide. So you now have the limit as t approaches 0, 1 over t plus 1, and then you can gradually substitute. You're going to have 1 over, where there's a t0 plus 1, so it's the 1, so you just have the 1 as the result. Okay, and then finally the last question under part 1 to do with these basic limits. We have the limit as x approaches 0, then you have x over root of 1 plus 3x, okay, and then minus a 1, separatory, not under the square root. So here you see, I gave you an example of question this one, question 9. I said even if it's on top, it's basically the same concept. So you know, if you substitute, you're going to have a 0 on top. So as a good practice, multiply by the conjugate. So 1 plus 3x plus 1 . So what you're going to remain with, by the way, feel free to pause the video and try this one out on your own. So the numerator going to remain with x multiplied by 1 plus 3x and then plus a 1. Denominator, you're going to have 1 plus 3x. Since when you multiply the like parts, the square root will go. And then negative 1 times 1 is just going to be minus 1. Right? So at this point, you have the limit as x approaches 0. So for the top part, you have x and then root of 1 plus 3x plus a 1. So on the bottom, 1 and 1 can subtract. So you only remain with a 3x there. So for the 3x, the x and the x can divide. So that you just remain with a limit as x approaches 0. And then you remain with what's in the brackets. So that's 1 plus 3x plus a 1 over a 3. You can gradually substitute the value of 0. So that part will be eliminated. We have a root of 1, which is just going to be like a 1. 1 plus a 1 is going to be a 2 over a 3 as our result or our solution to that limit. Yeah. So this is where question 1 ends. Okay. Alright, so we'll continue with question 2. Here we're trying to evaluate the limits that involves the infinity. So first one, the limit as x approaches infinity is what we're trying to look at. And then you have x squared minus 1 over x squared plus 1. So the basic idea that you need to know, and that I believe you already learned under our discussion, you know that the limit as x approaches infinity, whether infinity or negative infinity, if it's 1 over x, or any power of n, this you should know that it's equal to a 0. Why? You can actually try to observe this as you try to increase. If you're going to start from, let's say, 10, try 100, try 1,000, try a million. So you see that as you begin to increase the numbers below there, what do you begin to see? You begin to see that the value is going to be getting closer and closer to 0. So that's what it means. And this is actually true if you try to sketch a graph of any function in that form of 1 over x. Alright, so when you're given a fraction like this one, what you basically do is you need to divide by the highest power. Okay, highest power on both the denominator and the numerator. So this implies that on our next step, we're going to have the same limit as x approaches infinity. So if you check the numerator, what's the highest power? It is x squared. So divide by x squared. So we have x squared divided by x squared minus 1 over x squared. For the denominator, the highest power is also x squared, so divide the entire denominator by x squared. So after we've done that, on our next stage you say that you're going to remain with x as x approaches infinity, the limit as x approaches infinity. Divide that, you have a 1. Then the other part you also have a 1, but plus 1 over x squared. So at this point you are now able to distribute the limit. Okay, so you remain with 1 minus, so where we have the x, that's where we're going to distribute the limit. So 1 over x squared, and then over 1 plus the limit as x approaches 0 for 1 over x squared. So I told you to say, if you're going to have 1 over x and then you've got x approaching infinity, not 0, you understand that they're all going to be equal to 0. So you're going to have 1 minus 0 plus over 1 plus 0. So at the end of it all, you're going to have 1 divided by 1, which just gives us a 1. So the basic idea is the limit as x approaches infinity or negative infinity in the form of 1 over x or x to any power, the answer is a 0. Okay, so that concept is very important and it will help you in simplifying. So let's try to see what we can do for the other three. Feel free to pause the video and apply the same concept to the next question. So here we have the limit as x approaches infinity, and then we have 4x squared minus x minus 2 over 5x squared plus 4x plus 1. So for your own information, for people in a case where you have run out of time, just know that whenever you're trying to determine the limit of polynomials being divided, it's just get the coefficients of the highest powers. So coefficient on top is 4, on the bottom it's 5. So that would be your answer at the end of it all. Okay, so you understand that what you're going to do is you divide by the highest power, right? So the limit as x approaches infinity, don't forget our answer, our predicted answer is 4 over 5. So for the top part, you divide by x squared throughout, so you're going to have 4x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. We're dividing by the x attached to the first one. And then for the bottom, 5x squared, so the highest is x squared, so divide by x squared throughout, x squared, x squared. So you remain with the limit as x approaches infinity. So that will cancel, so you remain with a 4 minus 1 over x minus 2 over x squared. There we have a 5 plus 4 over x squared plus 1 over x squared. So you understand that there's this point, this is a point where we're going to distribute this now. So every part that is having x as a denominator is going to be a 0. And so at the end of it, we are going to have 4 over 5. I told you how to distribute in the previous example, so you can show that. So equally for the third one, you do the same. Here we have the limit as x approaches, this is t, as t approaches negative infinity, and then you have t squared plus 2 over t to the power 3 plus t squared minus 2. So for this one, we'll do the same. The limit as t approaches negative infinity, we'll divide by the highest power on top, it's t squared itself. So it will be t squared plus 2, so divide by t squared divided by, so for the bottom we divide by the highest power, which is t to the power 3. So t to the power 3, t to the power 3, t to the power 3. So what we have, so I'll just go the limit as t approaches negative infinity. So on top, divide, so you have 1 plus 2 over t squared. Denominator you have, that will divide, so you have 1 plus 1 over t, and then that's a minus 2 over t to the power 3. So all the parts that are having a denominator of a t will become zeros. So eventually you just remain with a 1. This is very important. Now we have an interesting one, that's the fourth one, which is dealing with a radical. The limit as x approaches infinity, x plus 2 root of 9x squared plus 1. So apply the same concept of dividing by the highest power, including under the denominator or under the square root. So you're going to have the limit as x approaches infinity. So you have on top divided by x, you have x over x plus 2 over x. Denominator you're going to have the square root. Now we divide by x squared 1 over x squared. So we have the limit as x approaches infinity. So this is going to be a 1, so 1 plus 2 over x, and then square root of 9 plus 1 over x squared. So you can distribute now the limit. So every part where we have x as a denominator, it will be 0. So we have 1 on top remaining, on the bottom we have root of 9 remaining, which will eventually be 1 over 3 as a result. Simple and straightforward, right? Alright, so under question 3, which involves now the asymptotes. So just a few things that I want you to understand under asymptotes very, very fast. So we have what we call the horizontal asymptotes, okay? And then we also have what we call the vertical asymptotes. Very important, right? So what is the horizontal asymptote? What's a vertical asymptote? So I'm sure you've seen graphs, the cases where you're going to have a line like this, and then you find that the graph, as it approaches that line, it's not cutting it, it's just getting closer and closer. So this is called a vertical asymptote. So that would be, for example, x is equal to 2. Horizontal ones equally, can give an example of certain radicals. So you find that they won't cut that line like that. That's a horizontal asymptote. It's avoiding to cut that line. Now there's another kind of an asymptote we call a slant or oblique asymptote. This is not neither horizontal or vertical. Instead, it's something that's slant. It can be something like that. And then you find that the graph maybe is like this. Okay, so this is called a slant or oblique asymptote. So there are cases that define when this basically gets to occur, and that's what we need to understand as we answer these questions. So for the vertical asymptote, simple and straightforward, these ones occur when the denominator is equal to 0. In this case, 1 over x when x is 0. If you're going to have 1 over x plus 2, or whatever denominator you're going to have, whenever the denominator is going to be equal to 0, that is going to be a vertical asymptote. Alright? Very important. Simple and straightforward. So vertical asymptotes occur when the denominator is equal to 0. And then for the horizontal, asymptote, there are two cases when it basically gets to occur. Two cases. The first case is where you're going to have the denominator being heavier than the numerator. So this is a normal fraction, x plus 1, for example, and then you've got x squared minus 1. You can see that the degree of the denominator is higher than that of the numerator. So you focus on the highest degrees, okay? Irrespective of how big the polynomials you're dividing are, you focus on the highest ones. In this case, we've got x to the power 2 and x to the power 1. So the denominator is, as we can see, has got a higher degree compared to the numerator, right? So therefore, in this case, y is equal to 0 is going to be the horizontal asymptote in every case when the denominator has got a higher power. And then the second case is where they are equal. For example, you may have x, 2x squared minus x, and then 3x squared minus 1. Here you can see that the degrees are the same. So in this case, what you do is you get the coefficients, which are 2 over 3, 2 and 3, which are the coefficients of the highest degrees of both the numerator and the denominator. So this is the other case where you can find the horizontal asymptote. Now the other case for the slant, as you might guess, the only kind of a fraction we've not talked about is the case where you have an improper fraction. So an improper fraction, something like, I think this is a good example, x squared plus 1 over x minus 1. This is an example of an improper fraction. So in this case, what you do is basically you divide. You can use long division or synthetic division to help you get the quotient, the remainder. Okay? So in such a case, the quotient is what is going to be the equation of the asymptote. An example I would give is if you're going to look at 3x squared minus 2x, if you know how to divide, if you've done your polynomials, try to divide, you see that you're going to get 3x minus 14 as your quotient, and then of course plus 55 over x plus 4. In this case, what you have here, that is an equation of the slant asymptote to this fraction. So these are the cases that you need to understand, and this is that's the summary of how you handle their different kinds of asymptotes, and they help you sketch the graph easy and faster. Starting with the first case, x plus 2 over x plus 3. This is a case where the degrees are the same. Of course, the simplest one is the vertical asymptote where the denominator is equal to 0. So equate our x plus 3 to 0, you find that x is equal to negative 3. So what is your vertical asymptote? Simple and straightforward. For the horizontal asymptote, where you've got the same highest power, same degrees, we said you get the coefficient. So it's 1 and 1. So therefore, the horizontal asymptote is y is equal to 1 over 1, which is a 1. Pause the video, apply the concepts to find 2. For the second one, we have x minus 1 over x squared plus 1. So this is a normal fraction. We said, of course, equates the denominator to 0 to find the vertical asymptote. So x squared is equal to negative 1. So you notice that you can't find the square root of a negative number. So therefore, the vertical asymptote does not exist in this case. There is no case where the denominator can be equal to a 0 because of the power 2 there. So this is not possible to get a real number. So vertical asymptote does not exist. Now let's try to find the horizontal asymptote. We've got this a normal fraction, we've got the denominator having a greater power, a greater degree compared to the numerator, because this is 2, that is the 1. So we said there y is equal to 0 becomes the horizontal asymptote. When you look at the third one, you have x squared plus 1 divided by x minus 1. Now this is a case where you're able to divide, right? This is the case where you're able to divide. Let me add on to this as the last one. Let me answer the others. For the fourth one, you can see that the powers are the same. We have got 5x squared plus 8x minus 3, and then you have 3x squared plus 2. So there, what do we do? The vertical asymptote. How do you handle vertical asymptote? The denominator equated to 0. So 3x squared plus 2 is equal to 0. You find that you have 3x squared being equal to negative 2, and then of course you can't as well in this case find the square root of a negative number, so we don't have a vertical asymptote in this case either. How do you find the horizontal asymptote? So we've got the same degrees, x squared, so it's going to be 5 over 3. Simple and straightforward. So done with the first one, the second one, the fourth one. This is also division. The last one, we can handle it. So we have x squared minus 3x plus 2, x to the power 3 minus 2x squared. So first of all, vertical asymptote equates the denominator to 0. So x to the power 3, how can we simplify this? So I've got x to the power 3 minus that. How about if you factorize x squared? What are you going to remain with? We're going to remain with x minus 2 equal to 0. So there are two possibilities. It's either x squared is equal to 0, or x minus 2 is equal to 0. Okay, so which is the case actually. If you plug in 2 there, you'll notice that you're going to have 8 minus 8, which will be a 0. If you plug in a 0 as well, it will be a 0. So these are the two possible, these are the two vertical asymptotes. X is equal to 0, x is equal to 2. So when you begin sketching this function, we don't expect it to cut the part where x is 0, which is of course the y-axis, and then x is equal to 2. So it should not cut these two lines. That's what it means for vertical asymptotes. Now for the horizontal ones, what do we do? Horizontal, observe x squared over x to the power 3. So the denominator has got a greater power. So in this case, y is equal to 0 is what? The horizontal asymptote. So therefore, y is equal to 0. Y is equal to 0. By now you should understand that that's the x-axis. So this is the horizontal asymptote. And then we said for the vertical, it's x is equal to 0 and x is equal to 2. So you shouldn't cut these lines. So when you're sketching this graph, it can be something that it's possible it can be something like this, and then it acts like this. I'm just trying to guess, I'm not sure how it's going to come out, but something like that. Okay, so we've identified the vertical asymptotes and the horizontal asymptote for the last one. So we now have the two special cases that will now involve division. So let's see how we can handle them. Okay, so we are now on the case that now requires to divide. So I hope you've learned long division. If you're new to that, just search long division translated institute on YouTube or synthetic division, so that you basically get to understand the two. However, I'll explain here. So how do you divide? So we have x minus 1, and then we're dividing into x squared plus 1. So I'll introduce imaginary parts to ensure that the powers are reducing in this order they are supposed to. So 0x is imaginary, and then we have a constant 1. So you can see we have 2, 1, and x to the power 0. So that's what we want. So let's try to divide now. So we'll divide by our x. X into x squared is going to be x. Now multiply that x with whatever is on the left, whatever we're dividing with. So we are going to end up with x squared minus x. And then we'll subtract. This will cancel, and then remain with 0x minus x. That will be positive x. Divide by positive x, again you're going to have a 1. And then you multiply the 1 with whatever is here. You're going to have x minus 1. And then we've got a negative there. You can drop the 1. So x minus x is 0. 1 minus 1, that's going to be a plus 2 because of this negative. Okay, so therefore what we have is we have the quotient is x plus 1, the remainder is 2 over the divisor, which is x minus 1. So therefore, what has this told us? So this tells us this is what we have here. The quotient is the equation of the slant asymptote. Okay, that's a linear, that's a line. And then of course the vertical asymptote is still going to be found in the same way by equating the denominator to 0. So we find that x is equal to 1 for the vertical asymptote. Simple and straightforward, right? Feel free to pause the video and try out the last one, 5. So I have x squared minus 3 over 3x plus 4. Feel free to pause the video and try this one out. How are we going to divide it? So we apply the same concepts. Okay, you divide. So we have 3x plus 4, and then we're dividing into x squared minus 3. So you can see here we've got an issue dividing 3x into x squared already. Let's try to apply synthetic division. Synthetic division requires us that we find the value of x by equating whatever we're dividing with to 0. So 3x is equal to negative 4, and then x becomes negative 4 over 3. So we'll use that. That's negative 4 over 3, and then we'll divide it into the coefficients or whatever we have. So we have x squared minus 3. So I'll introduce the imaginary parts. So we have 0x and then minus a 3. So the coefficients that we have there are 1, 0, negative 3. So 1, 0, negative 3. Well, how do you go about it? So first of all, drop the first coefficient and then multiply by that. So that would be negative 4 over 3. Add with a 0 to be negative 4 over 3. Multiply by negative 4 over 3 again to be 16 over 9. Now there what you have is negative 3 plus 16 over 9. So 16 over 9 in other terms. 16 over 9 minus 3. Common denominator 9, 16 minus 9 times 3 is 27. So that's going to be a 4 plus a 7, 11. So that should be negative 11 over 9. So negative 11 over 9. Hopefully my calculations are okay. So remember here what we had is x squared as the highest power. So your answers reduce. Okay. The last part is the remainder. So therefore you have x minus 4 over 3 as your factor, as your quotient, and then plus the remainder negative 11 over 9 divided by the divisor. So therefore this is a slant asymptote. Then for the vertical asymptote, as usual, equate the denominator to 0. So 3x plus 4 equated to 0. You have 3x being equal to negative 4. So x becomes negative 4 over 3. That's your vertical asymptote. So that's how you handle question 3 with positivity, confidence. Alright, so let's handle question 4, which is dealing with the first principle. So I've already explained what the first principle is. So the first principle is the case where they want you to build your derivatives from the very definition of the gradient, where we know the gradient is a change in y over change in x. So change in y as the function of x plus h minus the function itself divided by x plus h minus x, which reduces to f of x plus h minus f of x and then just h. And then of course we add the limit as h approaches 0. This is basically the first principle. Okay, so everything we're going to be doing will be based on that very equation. So when I look at the very first one, 3x squared, they want me to determine the derivative, find the derivatives in terms of x. So we already know that the derivative there is of course going to be 6x. Now how do we show that using the first principle? So our equation, the limit as h approaches 0. Now don't forget the equation is f of x plus h minus f of x divided by h. Of course don't forget the limit as h approaches 0. So for f of x plus h, it implies where there is x, you put x plus h in the function. So we're going to have 3x plus h where there is x squared, and then minus f of x, which means the original function itself, divided by h. We'll maintain the limit as h approaches 0, and then of course we have a 3. So expand what's in the brackets. You're going to have x squared plus that's going to be 2hx plus h squared, and then minus 3x squared over h. Now next step, we can distribute the 3. So we're going to have 3x squared plus 6hx plus 3h squared minus 3x squared. So this and that can subtract. We're still dividing by the h, don't forget. On our next step, the limit as h approaches 0, you can factor out the h on top so that you have h and then remain with 6x plus 3h over h. The idea is we can't divide by a 0, so the h has to be cancelled. Our goal is to always ensure that the h on the bottom is cancelled out. So you're now remaining with the limit as h approaches 0, and then you have 6x plus 3h. So now at this point, you know that wherever you have h is going to be a 0, so what remains is 6x as your derivative. That's how you use the first principle. Now apply whatever we've done here to every other question ahead of us. The second one is 1 minus root of x minus 1. Differentiate that function using first principle. So obviously I've already told you the limit as h approaches 0 will start by f of x plus h. It implies where there's x you put x plus h, so you're going to have a 1 over root of x plus h minus 1, and then minus the original function itself, which is just 1 over root of x minus 1 divided by the denominator, which is h in our equation. Next step, the limit as h approaches 0, we want to ensure that the h on the bottom is cancelled out. In this case, we have got fractions on top. Let's try to combine them. So common denominator will require us to have a product of the two. So we have x plus h minus 1 multiplied by x root of x minus 1. Then we divide. If we divide that, we're going to remain with the other part. So we have root of x minus 1 and then minus root of x plus h minus 1. That's basic computations of fractions. Okay, let me ensure you've gotten that. So that's just our numerator. Don't forget we have the limit attached. So the limit as h approaches 0 is attached. For the denominator, we have division by h. In other terms, we're multiplying the entire part by 1 over h. So that's what division is there. What do we do? So at this point, we've seen that we're dividing by 1 over h. Let me just bring it to the denominator so that you can clearly see the next step. So for the next step, what you do is you multiply by the conjugate, just changing the sign in between. Yeah, you understand why. So the conjugate implies we change the sign. So multiply both the denominator and the numerator of a fraction by the top part, changing the sign in between. So that will be root of x minus 1. We change the sign to be a positive, and then x plus h minus 1. Whatever you do to the numerator, do it to the denominator as well. Okay, now that is going to be a very important step, and I want you to be very familiar to this because this is going to be very useful to even the other questions that follow. So what you do here is, when you apply this by that, the square root will disappear. You're going to remain with x minus 1. Then this times that as well to be minus, and then the square root will disappear. So x plus h minus 1 will remain. Okay. For the denominator, we will not expand anything because we don't expect anything to cancel out. So we maintain them as they are. In the brackets, we have root of x plus h minus 1 multiplied by root of x minus 1 in brackets, and then we are multiplying with this part. I'll put it in brackets as well. Root of x minus 1 plus root of x plus h minus 1 in brackets. Okay, now this entire part is divided by h. Everything is being divided by h. So dividing by h, the entire part there. Now dividing by h is as good as multiplying by 1 over h for your information. I already mentioned that. Now let's try to proceed to the next step where we're saying the limit as h approaches 0. Now for the top part, you have x minus 1. Distribute the negative, you have minus x minus h plus 1. So clearly you can see that the x will subtract with the x there. This positive x will subtract with a minus x. Then the positive 1 will subtract with a negative 1. So essentially what's going to remain is just a negative h on top. and I think I can just show it there that the h is what is going to remain, and then the h will basically divide with that h. In fact, it's the negative h that basically remains. It's negative h, so negative h, and then the h will divide, so you remain with a negative 1 on top. So I have negative 1. Now let's distribute this, the h approaches 0. So wherever we have h, we're going to put a 0. So that part in the brackets, we're going to remain with root of x minus 1. The h has disappeared. And then multiply by root of x minus 1 as it is. And then the next part in the other bracket, it will remain as it is, plus the h will also disappear there, remain with root of x minus 1. So what we have now at this point now we have negative, let me simplify everything. So we have the limit as h approaches 0, and then you have negative 1. In fact, the limit can now disappear, so we have negative 1 remaining on top, and then on the bottom what we have is this times that will make the square root to disappear, so we just have x minus 1 in the first bracket. In the other bracket, this plus that will be 2. So that's a 2 of those coming twice. Everything else has disappeared. So is there any way we can better put this? There is. Negative 1, and then I can start with a 2 instead, and then x minus 1 if I want in brackets, and then root of x minus 1 if I want. I don't have to put it in brackets, but this is basically what you are ending up with as the derivative to the second part. Alright, so we'll continue now with question 3. So that's the function that is cosine 3 of x. We have to differentiate this using a first principle. So from first principles as well, don't forget the equation f of x plus h minus f of x divided by h, right? The limit, of course, as h approaches 0. So what we do, it implies where there is x, you put x plus h for the first part. So the limit as h approaches 0 for f of x plus h implies we put x plus h. Since we're dealing with cosine 3x, where there is x, we're going to put x plus h. Okay, that's the step we're going to make there. So we're going to have cosine and then 3, where there is x, we're putting x plus h, minus f of x, which is of course the function itself, cosine 3x, and then divided by h. This is all we are supposed to do. The limit as h approaches 0, we can distribute the 3. You understand that we are going to have cosine 3x and then plus 3h. You can still put that in brackets and then over h. So we can't substitute the value of h because we've got h as a denominator there, and you know the effect of that, it will make everything undefined. So let's try to expand using our trigonometry. We know our trigonometry at this point. So whenever we've got cosine, I call cosine to be selfish. So it will be cosine 3x, cosine 3h, and then sine comes after. So I have sine 3x, sine 3h, and then minus the cosine 3x there over h. Okay, we're getting there. At this point, what can we do? Do we have anything common that we can... So I can see cosine 3x is common, right? So the limit as h approaches 0, we'll factor out the cosine 3x. What remains? For the first part, we're going to remain with cosine 3h, the other part to just be a 1, and then minus sine 3x sine 3h over h. Okay, at least we're getting there. Now, some of the things that you have to know under the trig limits. You know that if you're going to have something like sine 3x or sine 3h, which we have in this case over 3h, and then apply the limit as h approaches 0, this is equal to a 1. And then for the cosine part, if you're going to have cosine 3h minus 1 over 3h, and then the limit as h approaches 0. This is going to be equal to a 0. You know that, right? So let's try to see the way we can come up with this. So let's distribute the limit. So the parts that don't have h are innocent. So I have cosine 3x. We'll now distribute the limit. The limit as h approaches 0 will apply to this part. So what we have cosine 3h minus 1. So as a smart student, divide everything by h. So if you divide everything by h at this point, this part will be over h, even that part will be over h. So therefore that h can apply here, and then minus what we have sine 3x, and then we'll distribute the limit to the other part. The limit as h approaches 0 to what? So that will be sine 3h over h. So now you know that you can't, the identities we have only applies if this and that, if those ones are matching. So we have to multiply both the numerator and the denominator by the 3 for that to work. So here we'll distribute the 3. So we'll have a 3 on top there, even there a 3. So on the bottom as well we'll have 3's. So what does that mean? So this part is going to be equal to a 0. That's an identity. That part will be equal to a 1. So the first part is going to be eliminated because of a 0. Then the other part you're going to remain with negative 3 sine 3x. Okay, so that's the derivative we're going to have. And that's basically true. Derivative of cosine, it's negative sign multiplied by the derivative of what is attached there. It's a 3. So negative 3 sine 3x is the result we have. Be at liberty of practicing. As a good student, you can try out sine 3x. You know obviously that the derivative there is going to be cosine 3x 3. So make sure you get that using the first principle. Okay. Now on the fourth one, we have a radical again, root of x squared plus 1. So f of x plus h, so let's don't forget our formula. The limit as h approaches 0, so root of x plus h squared plus 1 minus root of x squared plus 1 over h. So all we have is we just distributed in the function. Don't forget our function or our equation, f of x plus h minus f of x divided by h. Don't forget the limit as h approaches 0. So this one is simple and straightforward. You can't distribute h equal to 0 because it's going to make it undefined. So we'll multiply by the conjugate. So that step I'll omit it. So you know that when you're multiplying by the conjugate, it implies to change the sign in between. So for the numerator, you know that what's going to disappear will be the square root. So we are going to remain with x plus h squared plus 1 and then minus x squared plus 1 over h. Now at this point it implies we had multiplied by the conjugate of the top part, which implied the square root of x plus h squared plus 1, changing the sign in between, and then that is x squared plus 1. Okay, so let's expand that. So that's going to be x squared plus hx plus h squared plus a 1. We'll distribute the negative for the other part to be minus x squared minus 1. Let's identify what's cancelling out. That and that are subtracting. The negative 1 and the positive 1 are also going. What's remaining is hx plus h squared. I can put it there. So h squared plus hx. We can factor out the h. You factor out the h, you're going to remain with x plus h. So these can divide. So our goal is to remove the h from the denominator. So at this point, distribute the h is equal to 0 now. So 0 we have is h. What's remaining? So let's try to identify what will remain. So the limit as h approaches 0, for the top part you remain with x. For the top part you remain with x over, on the bottom the h will go, so you remain with x squared. The root of x squared plus a 1 plus root of x squared plus a 1. So eventually you have x over 2 of these being the derivative. Alright? And then for number 5, y is equal to 1 over x. That one is simple and straightforward. So for f of x plus h, it will mean 1 over x plus h minus 1 over x divided by h. For the fractions, common denominator is x plus h multiplied by x. So if you divide by x plus h, you're going to remain with x. If you divide by x, you're going to remain with x plus h as well. So don't forget the limit as h approaches 0. And then don't forget you're dividing by h as well. So here we're dividing by h. So equally you're dividing by h. Dividing by h, of course, I did emphasize it's as good as multiplying by 1 over h. The limit as h approaches 0. For the top part, if you distribute the negative, you end up with x minus h, remaining with only a negative h on top. And then on the bottom, you have x multiplying by x plus h. Okay? Now don't forget we are multiplying by 1 over h the entire equation. So h can basically now divide. We are always avoiding dividing by a 0, so that's why this h is always supposed to cancel out. So now at this point, what's remaining is the limit as h approaches 0. You have negative 1 on top over x and then x plus h. So where there is h, now you can put a 0. So you remain with negative 1 over x and then x plus 0. So that will just be negative 1 over x squared. Okay. And that's basically true. That's basically true if you know how to differentiate 1 over x. 1 over x is as good as x to the power negative 1. So if you're going to differentiate it, that's going to be negative 1 multiplied by the x. You reduce the power by 1 to become negative 2. So you have negative 1 over x to the power 2. And then for the last one, which is the final one, quite interesting. There we have y being equal to x over x minus 1. Simple and straightforward. Plug in. So the limit as h approaches 0. So for x plus h, it will mean we have x plus h over x plus h. So where there is x, I've just put x plus h. Now minus the original one, which is x over x minus 1 divided by the h. That's what we have at that point. And so, of course, all the same, common denominator. So common denominator is, of course, x plus h minus 1 and then x minus 1. That's the common denominator. Let me just move it a bit down. And then as you begin multiplying now, you notice that for the first one, if you divide that into this, you remain with x minus 1. So it will be x plus h, which is already there, multiplied by the x minus 1, and then minus the x, which is already there. If you divide that into this again, you remain with now the other part, x plus h minus a 1. Okay, we're getting a step closer. Don't forget we're dividing by h the entire part, so that's as good as multiplying by 1 over h. Are we any step closer? Let's try to simplify what we have. The limit as h approaches 0. So far we've seen that the conjugate multiplication only deals with the radicals, right? Everything else is just working out smoothly. Fractions, just simplify them as you would. So let's try to multiply that for this fraction. For what? X times x is x squared plus hx, and then that's minus x, and then minus h, is it? And then for the other part, distribute the negative x. So I have negative x squared, negative hx, and then positive x over the denominator remains as it is. We don't like tampering with it. Okay, so that we maintain the 1 over h as it is. So our goal is to ensure that on top we remain with h and somehow cancel the one that is out there. So the limit as h approaches 0. Right? So let's cancel out what's common. X squared will cancel, minus hx plus hx, positive x and negative x. What remains is negative h on top, and then on the bottom we have x plus h minus 1, x minus 1, and then 1 over h. So that can also go away. What remains at this point is the limit as h approaches 0, and then negative 1 over x plus h minus 1, and then x minus 1. So whatever is h, we're going to put a 0, and so that will disappear. You have negative 1 remaining over x minus 1 coming twice, so that would mean to be x minus 1 to the power 2. Okay, so I believe if everything, if all our computations are okay, this is the derivative for that other one. And of course you can try it by using the quotient true to verify all our solutions. Okay, so this is where we end with question 4. Alright,
so we'll now look at differentiating in terms of x. So we have quite a number here. So we have questions involving the product rule, we have questions involving the logarithms, questions involving the quotient rule, logarithms, product, chain rule, logarithm, product rule. So we'll solve them. So question 1, as you can see, it's a product. So we have x squared multiplied by x to the power 3 plus x to the power 4. So this is a product of two functions. Okay, so let's call the first function to be x squared, and then the other one to be v to be called let's have the other side x to the power 3, right? So we'll call it, our v will be called x to the power 3 plus x to the power 4, right? So now we have to differentiate all these. So u prime is going to be 2x, then on the other side v prime is going to be 4 x to the power 3 plus x. The power has to reduce by a 1, right? We are applying the chain rule to differentiate v. So when the power reduces by 1 becomes 3, don't forget you're supposed to multiply by the derivative of what is in the brackets. So that is 3x squared plus 1. Okay, so due to lack of enough space, so let me move it a bit. So that's what we have. So we have applied the chain rule to differentiate v. So a basic idea of a basic argument of the product rule is it doesn't matter what you start with. So I'll start with x squared, and then I'll multiply by the derivative of the other part, which is that. So that is 4 open brackets. So I'll start with the first part, x to the power 3 plus x to the power 3 multiplied by 3x squared plus 1, and then plus, we can now go to the second part, which is x to the power 3 plus x to the power 4 multiplied by the derivative of the very first part, which is 2x. This is what the product rule tells us to do. Now at this point, 4 times that is going to be 4x squared. I can start with that part if I want to, or instead I can factorize. I can see this is common, So what's the highest common, or maybe if we are going to do that anyway, if we're going to do that, it means let's first of all multiply. So we have 4x squared, and then we remain with x to the power 3 plus x to the power 3, and then we have 3x squared plus 1 in brackets. Now the other part we will have 2x and then x to the power 3 plus x raised to the power 4. So this is where we've ended, and if you want you can take an extra step by simplifying the solution by factorizing. You can see x is common. Let me just say 2x is common, right? So we can have 2x. So in the very first part, what remain is what? If we pull out the 2x, we remain with a 2x. And then what else can we pull out? Now we can pull out this part. We can see this is common, this is common. So the highest common power is 3. So I have x to the power 3 plus x to the power 3. Now in the brackets, what remains? When we remove 2x from 4x squared, we're going to remain with 2x, and then we're also going to remain with 3x squared plus 1 for the first part, plus the other part 2x is already pulled out, and then we'll remain with a single power since 3 has already been pulled. So x to the power 3 plus x. So of course you know what is in the brackets can be simplified, right? So we have 2x, x to the power 3 plus x to the power 3 in brackets. So 2x times that is going to be 6x to the power 3 plus 2x plus x to the power 3 plus x. That's what we have there, right? So now at this point we know the like terms, right? So the like terms are 6x and that. So we are going to have 2x and then x to the power 3 plus x to the power 3 in brackets. So you remain with 7x to the power 3 plus 3x. So you can end here, but you could have ended even just before this. There's no harm. The basic idea is they want to see if you understand what method you're going to use to simplify any given question. So the next one is involving now the natural log. Natural log of 1 minus x squared, 1 plus x squared. So I want you to pay particular attention to what we can do here. So whenever you've got a natural log or any log per se, the formula is very, very simple. Okay? So whenever you've got a natural log of u, what's the derivative? Derivative is going to be u prime over u. That's all. Very, very simple and straightforward, right? So what that means is, if you're going to have a natural log of x squared, the derivative of x squared is 2x, the derivative, and then you maintain whatever is attached to the natural log x squared. So this gives you 2 over x. That's how you differentiate the natural log. So you can do the same. You can literally do the same here. How? First of all, differentiate this using the quotient rule. Put your answer on top and then divide by itself the way it is. That's one way of handling it, right? Simple and straightforward. Now I don't want to use this method. I want to apply a bit of some logarithms. So logarithms tells us when you're going to when you've combined the log of two different things that you're dividing, it implied that we were sharing what? The log, sharing the base. So I can expand this using logarithms. This is natural log of 1 minus x squared. Now when you're subtracting, it implies, or when you're dividing, it implies you were subtracting. So minus the natural log of 1 plus x squared. So these are just logs. Now at this point this is going to be easier. Now what's the derivative of what is in the brackets? It's negative 2x. We'll maintain whatever is in the brackets. The other part as well, the derivative of that is going to be 2x. We'll maintain what's in the brackets, 1 plus x squared. So this is simple and straightforward, right? Than going by the quotient rule, which you can also easily do. Okay. Now of course, if you want, you can simplify this beyond this point, come up with a common denominator. If you want to find the same answer that you find if you go the other way, so you want to simplify this, right? So 1 minus x squared plus 1 plus x squared, that's the common denominator. Okay, so After I divide by that, what remains is the other part, so it's negative 2x multiplied by 1 plus x squared, and then minus, and then you have 2x on top multiplying by 1 minus x squared. At this point, what we have, so negative 2x multiplied by that to be negative 2x minus negative 2x to the power 3. This part, negative 2x plus 2x to the power 3 over, so if you check what we're multiplying on the denominator, it's more like a conjugate because the sign is just changing. So it will just be 1 times 1, and then negative x squared times negative x squared will be negative x to the power 4. If you want, you can go step by step, you still end up with the same result. So let's see what's subtracting here. So this part and that part are of opposite signs. So on top we remain with negative 4x over 1 minus x to the power 4. Okay, so that's where you end for part 2. Alright, so question 3 is very simple. Just apply the question true. So feel free to pause the video and try it out. So we have 1 plus x to the power 3 divided by x squared, right? So we have two different functions dividing, so we'll use the quotient rule. Quotient rule tells us if you're going to have u over v, the formula that you can use is v and then u prime minus u v prime over v squared. Okay, so if we're going to let our u be what is on top, we can go on and substitute in the function or in the equation there. So what is our v? Our v is the denominator, x squared. Now what is u prime? U prime implies you differentiate whatever is on top, right? Because our u is equal to that. So our u is equal to 1 plus x to the power 3. What's the derivative there? So the square root is the same as what? The square root is the same as raising something to the power half. So if we're going to differentiate it, it's going to be half 1 plus x to the power 3, reduce the power by 1, it will be negative half, multiplied by the derivative of what is in the brackets, that's going to be 3x squared, right? So at that point, what we're going to have after simplifying this, 3x squared over the 2 after multiplied by the half and that, and then in the brackets we're going to remain with 1 plus x to the power 3 raised to the power negative half. We know you can take that to a denominator so that you can have a positive power, right? So we can have 1 plus x to the power 3 raised to the power half. Now positive half is the same as the square root. So therefore, our derivative becomes 3x squared over 2 root of 1 plus x to the power 3. Okay, we can continue in the formula. So minus u, so our u is our numerator, so that is root of 1 plus x to the power 3 multiplied by v prime. V prime is the derivative of what is on the bottom, which is going to just be 2x, right? Over, now well, the denominator is going to be v squared, so that will be x squared squared. I think at this point all we are remaining with is just now the idea of us simplifying whatever we have. Can we simplify it beyond this point? That's the question. So this times that is going to be 3x to the power 4 and then over 2 root of 1 plus x to the power 3, right? And then minus the other part. What are we remaining with? So we're remaining with if you multiply this times that, you're going to have negative 2x and then square root of 1 plus x to the power 3, of course, over what's on the denominator, which is x squared squared, which is going to be x to the power 4. So at this point, dividing by that is as good as multiplying the entire thing by 1 over x to the power 4. So if you multiply the first part by that, you notice that they will divide, right? So you essentially remain with what? You're going to remain with a 3 on top, and then 2 root of 1 plus x to the power 3, and then of course this times that you remain with only a 2, so minus 2 root of 1 plus x to the power 3, and then on the bottom we have x to the power 3. So basically at this point you are done with the third one. Okay, so let's continue with the fourth one now. So here we have the natural log of 2 plus cosine of x over 3 minus sine of x. So how do we basically get to differentiate this? How do we go about it when it comes to differentiation? So all the same, I would advise you pause the video and try it out. So initially I said you're supposed to expand this, right? When you're dividing, it means if you separate them with the same base of the log, we are going to subtract. So this is natural log of 2 plus cosine of x, and then minus natural log 3 minus sine of x. Okay, so at this point we understand that for natural log, I said whatever is attached, the derivative of it over the original is the derivative. So what's the derivative of 2 plus cosine of x? So you know that the derivative of a constant is a 0. Now derivative of cosine is negative sine. Okay, derivative of sine is cosine. Okay, take note of that. So derivative of cosine is going to be negative sine over the original, which is 2 plus cosine of x, and then minus, for the other part, what's the derivative of 3 minus sine of x? The constant will cancel out. Derivative of negative sine, sine maintains the sign, so if it's a negative sine, it will be negative cosine. So negative cosine of x over the original, right? Which is just 3 minus sine of x. So at this point we have negative sine of x plus cosine of x. Okay, this is over 2 plus cosine of x, and then that is 3 minus sine of x. I think this is okay to end at this point. Very, very fine. Okay. So you clearly show that you understand how to go about the logs. You clearly understand how to basically differentiate them. You can go by the other method and see, which will require you to first of all use the quotient rule, determine the derivative what is in the brackets, and then divide by the same one, 2 plus cosine of x over 3 minus sine of x. So try this one out and see if you're going to end up with the same result. And if not, it means you can basically go on and simplify this beyond this point, which is not necessary. The next one is product rule. So pause the video and try it out. So I've already explained how you basically differentiate an exponential. So how do you differentiate an exponential? An exponential differentiated by multiplying by the derivative of the power. So what's the derivative of negative 3x? That's a negative 3. So therefore, if you multiply by negative 3, what you have is a derivative. Okay? So therefore, if we're going to say let our be x squared, u prime is 2x, our v is e to the power negative 3x, therefore v prime becomes negative 3. So notice that for an exponential, the power doesn't change. So therefore y prime, it doesn't matter what you start with, but you need to multiply these. So if I start with x squared, I'm supposed to multiply by the derivative of the other part, which is negative 3, e to the power negative 3x, and then plus, so the other part, e to the power negative 3x multiplied by 2x. So at this point, what's common? Anyway, you can factorize for yourself, so I'll leave it at this point. When you multiply this times that, it will be negative 3x squared e to the power negative 3x, and then the other part will be plus 2x e to the power negative 3x. At this point, this is where you can now see what is common, right? You can see that E is common. You can also see that X is common. So you can have X and E being common. And in the brackets, what remains for the very first part, you have -3 and an X remaining. Then the other part, you just have a 2 remaining. So that's what you have. That's what you have after differentiating that. Now when you check the next one basically involves just the chain rule. Y is equal to cosine x to the power 3 minus 4. How do you go about it? So our y prime is going to be, ask yourself, what's the derivative of cosine? What's the derivative of cosine? So we say derivative of sine is cosine. Derivative of cosine is negative sine. Just this will help you. So the derivative of cosine is negative sine. So you have negative sine x to the power 3 minus 4. Now don't forget that you're supposed to multiply by the derivative of what is in the brackets. Derivative of what is in the brackets is 3x squared. The constant minus 4 just disappear. So what you end up with would be negative 3x squared and then sine x to the power 3 minus 4. So what is your derivative there? Alright, so we'll do a second from last question where y is equal to the natural log of ex squared. Let me write that properly. So we've already looked at the question that relates to this, so pause the video and try this one out. So e to the power x squared over e, that's not e, that's x squared. Okay, so I've already shown you the ways to go about it by expanding the logs, but let me show you the other alternative way now of going about it. So what you'd want to do is, first of all, determine the u prime of whatever is in the brackets. What we have in this case, we have e to the power x squared and then over x squared. So we are supposed to apply the quotient rule here. So the quotient rule, remember, the formula is, if you're going to have u over v, our formula is going to be v u prime minus u v prime, right, over v squared. So our v is what's on the bottom. So we have x squared. Now u prime, which is the derivative of whatever is on top, you say it multiplied by the derivative of the power. Derivative of x squared is 2x. So I have 2x attached to the exponential. The exponential, the power doesn't change. And then minus u. U is e to the power x squared. And then v prime. V prime, the derivative of x squared is 2x. Divided by v squared, which is x to the power 4. Right. Okay. So that's where we are at this point. Can we simplify it beyond that point? So if you multiply this and that, you're going to have, that's going to be 2x to the power 3 e to the power x squared as it is minus 2x e to the power x squared as it is over x to the power 4. Now don't forget that at that point you're supposed to divide by the original as it is in the brackets. So that is e to the power x squared over x squared. Now I've already shown you that dividing by something is as good as multiplying by the reciprocal, right? So if we're saying we're dividing by e to the power x squared over x squared, it's as good as multiplying by the reciprocal, meaning that you swap them. So it's the same as we're multiplying by x squared over e to the power x squared. Okay, so let's move to the next step. So if you do that, if you do just that, let's see what you're going to have. So take this to be individual terms, this and that to be individual terms. Okay, so x squared times whatever is on top, we're going to have 2x to the power, that will be to the power 5 now, that will be x to the power 3, and then over x to the power 4 will be attached by ex squared. So you notice that ex squared is now common everywhere, right? It's attached at every point. So you can actually factorize it on top. So if you do pull it out, e to the power x squared, it is going to divide with 1 on the bottom. So what remains as your solution is 2x to the power 5 minus 2x to the power 3 over x to the power 4. Of course, you can go on and simplify that. You know that since you've got x to the power 5, 3 and 4, the minimum power is 3. So you can pull out x to the power 3 on top, remain with 2x squared minus 2 over x to the power 4, which can be split. So this and that will go. So you end up with 2x squared over x as a simplified solution. Okay. Now for the last one, we apply the chain rule. Okay. So when you see y is equal to cosine squared and then x to the power 3 minus 4, the meaning there is it's like what you have is cosine and then x to the power 3 minus 4 and then all this is raised to the power 2. That's what it means. Okay, so cosine squared of x is not equal to cosine x squared. These are two different things. Okay, this means cosine of x raised to the power 2. That's what it means. With that understanding, we'll let our u be equal to whatever is in the bracket. So what we have, y is equal to u to the power 2. Now we know that our u is equal to cosine x to the power 3 minus 4. So we can basically determine du there. So our du dx, what's the derivative of cosine? Negative sign. So multiply by the derivative what is in the brackets, that's going to be 3x squared. Okay, if you simplify that, you're going to have negative 3x squared sine x to the power 3 minus 4. Differentiate this in respect to u. It's going to be called dy du, which will be 2u. Now for us to get du dx, for us to get dy dx, it's a product of dy du multiplied by du dx. So dy du is 2u, and then our du dx is this part. So negative 3x squared sine x to the power 3 minus 4. Now our u is basically whatever was in the brackets, right? So we said cosine of, so that would be 2 cosine x to the power 3 minus 4. Now we are multiplying by negative 3. Negative 3x squared sine x to the power 3 minus 4. So this time that we're going to get negative 6x squared and then sine x to the power 3 minus 4 cosine x to the power 3 minus 4. So what is basically our derivative by applying the chain rule there? If you think you can simplify it to further than this, please feel free to go on. Alright.